What if everything you know about reality doesn't appear to be as it seems? What if the rules that govern the world you see, the solid ground beneath your feet, the predictable path of a thrown ball, simply vanish when we look too closely? There is a hidden layer to our universe, a realm of the impossibly small, where logic twists and the impossible becomes routine. This is the domain of quantum mechanics. It is the study of the subatomic, the electrons and photons that build our world, and it is a place more bizarre than any science fiction. Today, we venture into the quantum shadow. Quantum entanglement, the phantom link. Imagine a connection so profound, so instantaneous, that it defies the universe's ultimate speed limit. This is not magic. This is quantum entanglement. Think of two particles, born from the same event. They are linked. If one has an up spin, its twin, by cosmic law, must have a down spin. Change the spin of the first, and its partner instantaneously knows. It flips in perfect, silent harmony. One on Earth, the other 4 light-years away in the void near Proxima Centauri. At the speed of light, a message between them would take 4 years, but the quantum link takes no time at all. Information travels faster than light, a clear violation of cosmic law. Einstein called it spooky action at a distance. He was deeply troubled by it. But in 1972, Clauser and Friedman proved it was real. The universe, it seems, allows for phantom conversations across the void. The question is, how? Quantum tunneling, walking through walls. You stand before a solid mountain. Classical physics says you must climb it, but in the quantum realm, you can simply walk through it. This is quantum tunneling. A particle, like an electron, can hit a barrier it seemingly has no energy to cross and simply appear on the other side. It doesn't go over. It finds a ghostly passage through. It's the science behind Harry Potter walking through the wall at King's Cross. But this is not fiction. It's the reason the sun shines, enabling nuclear fusion at its core. It's the principle behind the device you're using right now, powering the semiconductors in your computer. In our world, walls are solid. In the quantum world, they are merely suggestions. Wave-particle duality. The split personality of reality. Is light a wave, or is it a stream of particles? The answer, defying all common sense, is both. Quantum wave-particle duality reveals that every fundamental entity has a split personality. Electrons and photons act as solid, discrete particles when you look for a particle, but when you're not looking, they behave as spread-out ethereal waves. It's as if a single person could be in one place and yet simultaneously be a diffuse cloud of probability, existing everywhere at once. Quantum computing, the ghost in the machine. Our classical computers think in binary, a simple language of yes or no, 1 or 0. But the quantum world speaks a more ancient and powerful tongue. Quantum computers use qubits. A qubit is not a 1 or a 0. It is a 1 and a 0 at the same time. This state, known as superposition, allows a quantum computer to explore countless possibilities simultaneously. Where a normal computer would plod through a maze one path at a time, a quantum computer walks all paths at once. It is a technology that doesn't just calculate faster, it calculates in a fundamentally different dimension. Quantum superposition, the unseen state. Imagine a coin spinning in midair. Before it lands, is it heads or tails? The quantum answer is, it is both. It exists in a blurred state of all possibilities, a superposition. This is the true state of a quantum particle. An electron doesn't occupy a single energy level. It occupies all possible levels at once, a ghost of potentiality. It is only when we force it to answer, when we measure it, that this ghost collapses into a single solid reality. The act of looking makes it real. The double-slit experiment, the mystery deepens. The proof lies in one of the most famous and unsettling experiments in all of science. Fire particles at a screen with two slits. When you don't watch them, they behave like waves, creating an interference pattern, as if each particle went through both slits at once and interfered with itself. But the moment you place a detector to see which slit the particle actually goes through, the magic stops. The particles suddenly behave like well-behaved little bullets, and the wave pattern vanishes. It's as if the particles know they are being watched. The very act of observation changes the past behavior of the particle. This implies a connection between consciousness and the fabric of reality that we still cannot explain. Schrödinger's cat and the observer. This leads us to the most famous thought experiment of all, Schrödinger's cat. A cat is placed in a box with a radioactive atom. If the atom decays, the cat dies. If it doesn't, the cat lives. According to quantum rules, until we open the box, the atom is in a superposition, decayed and not decayed. Therefore, the cat is both alive and dead, a living ghost. It is only when we lift the lid and observe that the universe is forced to choose, alive or dead. Some theorists take this further. They propose that the universe doesn't choose. Instead, it splits. In one reality, you find a live cat. In another parallel universe, a copy of you finds a dead one. Every observation could be birthing a new cosmos. From the uncertainty principle, which tells us we can never know everything, to quantum field theory, which suggests that particles are merely ripples in invisible cosmic fields. The quantum world is a shadow universe, operating just beneath the surface of our own. It is strange. It is counterintuitive. It challenges our very notion of what is real. But this bizarre and mysterious realm is not just abstract philosophy. It is the engine of our modern world. It powers our technology, dictates the chemistry of life, and holds the key to our future. The quantum shadow is not just out there. It is the foundation of everything you are and everything you see. The only question that remains is, what else is it hiding? What do you guys think? Let me know in the comments. And as always, don't forget to like and subscribe to Brainwave. Until the next time, take care.